airframes.
The F-35B Lightning II represents more than an incremental advancement, a paradigm shift.
This single airframe synthesizes capabilities previously relegated to multiple specialized aircraft.
Those in Corbin. This analysis will deconstruct the intricate design trade-offs and technological innovations that define the F-35.
We will examine how this aircraft functions not merely as a weapon, but as a networked information hub, fundamentally.
The F-35B is not just a jack of all trades. It is a meticulously engineered system.
The F-35B Lightning II is the physical manifestation of a strategic demand for unparalleled operational flexibility.
It is conceived not merely as a fighter, but as a synergistic capability designed to consolidate the...
It aims to integrate the air-to-ground prowess of the F-16, the basing flexibility of the AV-8B.
This ambitious consolidation presents one of the most significant engineering challenges in modern aeronautics.
For its primary operator, the U.S. Marine Corps, the F-35's defining feature is its ability to operate from... This capability liberates tactical air power from the constraints of long, conventional runways.
However, integrating this short takeoff vertical landing system necessitates profound design compromises.
The very components that enable vertical flight, most notably a 1.2-ton lift fan and...
This results in a reduced operational range, a critical trade-off accepted in exchange for its unique basing flexibility. The core challenge of the F-35B, therefore, is not just in achieving each of its multi-role functions.
A core design tenet of the F-35B is low observability, a characteristic frequently misunderstood as invisibility.
The strategic objective of stealth is not to render the aircraft undetectable, but to critically delay and...
By minimizing its radar cross-section, the F-35B effectively shrinks the engagement range of enemy radar systems.
For a fighter, this provides the decisive tactical advantage. First look, first shot, first kill.
Achieving this low RCS dictates the aircraft's fundamental shape.
The primary threat, specular return, occurs when a radar wave reflects directly back to its emitter, much like light from a mirror.
This is avoided by eliminating large, flat surfaces and ensuring that all external angles are meticulously controlled.
The most problematic design feature for stealth is the corner reflector, where two surfaces meet at a 90-degree angle.
The B-2 bomber controls this, while the B-2 bomber does this by eliminating the tail entirely, a flying wing design that compromises maneuverability.
The F-117 Nighthawk utilized a V-tail as a compromise.
The F-35B employs a more advanced solution. It retains its horizontal and vertical stabilizers for superior...
Beyond its fundamental architecture, the F-35B's stealth integrity is maintained through a suite of advanced material sciences and applied engineering solutions.
A classic vulnerability is the engine intake.
Top-mounted intakes, as seen on the B-2, are shielded from ground-based radar but perform poorly during high angle of attack maneuvers.
Conventional side intakes, like the F-16s, require a boundary layer diverter to prevent slow, turbulent air from entering the engine.
This diverter creates a gap that is a significant liability for RCS.
The F-35B solves this with a diverterless supersonic inlet.
This seemingly simple bump generates a compression wave that pushes the boundary layer away from the inlet.
That you repart. This attention to detail extends to every surface.
Radar waves can travel along the skin of an aircraft and scatter when they hit a sharp edge, such as an access panel or weapons bay door.
To mitigate this, every unavoidable gap on the F-35B features serrated or sawtooth edges.
This pattern breaks up the radar waves, scattering them in multiple, low-energy directions rather than one coherent return.
Furthermore, the skin itself
is a critical component.
The F-35B is coated in a specialized radar-absorbing material.
A 2010 Lockheed Martin patent details a carbon nanotube-infused composite designed to absorb
This range is significant as it covers the operating frequencies of advanced surface-to-air missile systems, such as the S-400.
This multi-layered defense, shape, edge treatment, and absorption creates a comprehensive, low observable signature.
The F-35B's most defining and visually astounding capability is its transformation for vertical flight.
This is enabled by a system of unprecedented complexity, centered on a massive, contra-rotating lift fan.
This fan, capable of generating 85 kilonewtons of vertical thrust, is a marvel of engineering.
To minimize its significant weight penalty, 0.2 tons, it is constructed from advanced materials.
When the pilot initiates the transition to hover, a clutch engages a drive shaft running forward from the main engine. This shaft transfers a staggering 29,000 horsepower to a bevel gear system, spinning up the lift fan.
This action creates a massive low-pressure zone above the aircraft, violently sucking air downward.
Engines. The design of the fan's hood door is critical. Early X-35 prototypes featured 2 side-opening doors, but
This configuration was found to be more efficient,
helping to funnel air into the fan and improve pressure recovery.
This intricate, powerful, and heavy system is the cost of entry for the F-35B's unique
The lift fan provides the forward column of vertical thrust, but the rear column is provided by the main engine itself, the Pratt & Whitney F-135.
This engine, derived from the F-22 Raptor's F-119, was modified for the F-35's varied missions.
It features a much larger fan and higher bypass ratio, granting it immense thrust, 191 kilonewtons in. This design choice represents a crucial trade-off. It provides the raw power needed for vertical lift and efficient cruise. The F-35 was optimized for loiter time and brute thrust, not pure speed.
To direct this thrust downwards, the F-135 is equipped with a 3-bearing swivel nozzle.
This nozzle consists of 3 airtight, angled segments that can rotate relative to one another.
For short takeoffs, it vectors thrust to a 45-degree angle, combining with a lift fan to launch the plane from extreme.
For a vertical landing, all 3 segments rotate in concert to direct the full 191 kilonewtons of thrust at a 90-degree angle.
This precarious balancing act, hovering on 2 columns of air, is inherently unstable.
Therefore, a third system is required for stability. Roll nozzles, located in each wing.
These nozzles siphon high-pressure bleed air from the engine's bypass duct, providing precise thrust to control the aircraft's roll.
These 3 components, the lift fan, the 3BSN, and the roll nozzles, are all orchestrated by a sophisticated.
While its aerodynamic and propulsion systems are revolutionary, the F-35B's true lethality lies in its digital core.
Its greatest strength is not as a standalone fighter, but as a node in a network.
This begins with the pilot's interface.
The traditional forward-facing heads-up display is gone, replaced by a helmet-mounted display. This helmet projects all critical flight, navigation, and targeting information directly onto the pilot's visor.
This data is fed from a suite of sensors, including the AN/AAAQ distributed aperture system.
This allows the pilot to look through the floor of the cockpit and see targets below.
This is supplemented by the AN's Electro-AAQ.
The crown jewel of this system is the AN/APG-81 active electronically scanned array radar.
Unlike a traditional mechanical radar, which physically points a single dish, the ACE in a radar uses...
By minutely shifting the phase of the radio waves from each module, it can steer the radar beam electronically using constructive and destructive interference.
This allows it to track, jam, and engage multiple targets in multiple directions simultaneously, with no moving parts. This powerful antenna also handles high bandwidth communication through the multifunction advanced data link. MADL and PreventDL. MADL is a low probability of intercept data link that allows a flight of F-35s to securely share all their sensors.
This hive mind capability gives each pilot unparalleled situational awareness,